Hello and welcome to another episode of AWS Cloud Bytes Architecture series. I'm your host Bhavesh Kumar. Friends, if you like these videos, please share, subscribe, and click the notification bell icon for future updates. Also, comment on topics that you want me to cover. Today, we are going to discuss about AWS Cloud Core Infrastructure and the scope of various services that we are using. The first thing that we hear about AWS Core Infrastructure, it starts from a region. There are many AWS regions. We have, in this picture, we are depicting US East 1, you have US East 2, West 1, West 2, and many more. So a region is primarily a AWS geographical location, you can say. The way region is defined is that each region is isolated from other region so that in case of any kind of disaster, both regions can work independently. If one region is down, the other region should be able to function. This region is depicting the East Coast. Each AWS region is designed to be isolated from the other AWS regions. This design achieves the greatest possible fault tolerance and stability. You can see AWS local zones, AWS wavelength, AWS outposts. What is a local zone in AWS? A local zone is an extension of an AWS region that is geographically close to the users. And local zones are only, as of now, available in US West, Oregon region. We're not going to deep dive in that. That should be a topic of a different episode. The next one is wavelength. AWS wavelength enables developers to build applications that deliver single-digit milliseconds latency to mobile devices and end users. AWS developers can deploy their applications to wavelength zones in AWS infrastructure deployments that embed AWS compute and storage services within the telecommunication providers' data centers at the edge of the 5G networks and seamlessly access the breadth of AWS services in that region. What are AWS outposts? They bring native AWS services, infrastructure, and operating model to virtually any data center, co-location space, or on-prem facility. You can use them very much like you're using a service in the cloud. So your AWS API, tools, infrastructure across, whether it is a on-prem or AWS cloud, they give you a truly consistent hybrid experience. We are currently using Outposts for a similar kind of setup where we are running some applications on-prem, and in order to get to our domain, run in a truly hybrid environment, we are using Outposts. We already discussed about region. Region is a geographical location. Let's bring in some more components under that region. What exactly is there in a region? So in this picture, you see that we have added 3 availability zones in a region. A region can have, if you look at the relationship, the region can have 1 to many availability zones. Usually they will have 2, but for the sake of simplicity, I'm just keeping 3 in this picture. What is an availability zone? An availability zone is basically a data center. Within that geographical location, there will be many data centers, and each data center brings in an availability zone. So if you're running an application within an AZ, you can have your application hosted, or you can have your application hosted in multiple AZs within that region. And the good thing is, like, if one AZ is down, your application can still function using the second AZ. This is not a good scenario for a disaster recovery, but this is within the AZ. Each data center over here has redundant power, networking, connectivity in an AWS region. Let's add in more components to this diagram. Let's come to the building block where we start saying VPCs. In this picture, you'll see that we have added 2 VPCs. Each VPC has access to all the availability zones. So you can see the cross-cutting picture over here where each VPC has depiction showing all 3 availability zones. So both VPC 1 and VPC 2 here with 10.0.0.16 and 172.16.0.0/24 is available with all 3 AZs. Now, what is a VPC? VPC stands for Virtual Private Cloud. It is your own virtual network inside AWS. You control its IP range. You define subnets. You define its route table, security groups, gateways, etc. Why do you need a VPC? You can say that you need a VPC just because you have strict networking requirements. You want to govern your own IP ranges. You can bring your own IP and CIDR block. Now, the CIDR block controls the size of your VPC. CIDR or CIDR. Now, why do you want to bring your IP addresses? Some of the IP addresses have fair market value, such as 8.8.8.8 belongs to Google. They are whitelisted, they are good for SEO and other things. And also, like, you might have a strict requirement of just keeping that IP address. So this can be done in AWS now. VPC provides you a shell, or you can say an exterior wall for your network, where you can build your own utopia in the cloud. Amazon VPC supports 5 IP addresses. So there are like 5 CIDR ranges that you can define. In this case, like you have 10.0.0.0/16. You can have 4 more IP ranges within this particular VPC. One of them is primary and rest of the 4 are secondary. The CIDR notation can start from 16 to 28. Your IP address range at a lowest can be like /28 CIDR block. The IP address range for your VPC should not overlap with the IP address range of your existing network. You can do that, but there are other networking complications that will arise, due to which an overlap is not recommended. You can have 5 VPC per region. So in this particular region, you can see a VPC belongs to a region. It is not across multiple regions. And in this region, you can have 5 VPC, but that's a soft limit. I'm going to add a URL in the description giving additional information about VPCs. Let's add additional building blocks in VPC. So what does we have in a VPC? Once you have your VPC, you need to create subnets. Now, as the name implies, a subnet is a portion of your network. So a subnet is also defined by an IP range, and its CIDR block is taken from the parent VPC. So a subnet is bound to a specific availability zone. You cannot have a subnet between 2 availability zones. As you can see in the VPC with IP range 10.0.0.0/16 CIDR block has 6 subnets, 2 subnets in each of the availability zones. The colors usually, as per the tool I'm using, colors, green color is a public and the blue is the private subnet, but we'll come to that. Just think these are just CIDR blocks, sub-blocks of the CIDR that we have defined at a VPC level. You can have public or private subnets, as I already mentioned. In a 3-tier architecture, suppose you can have a data subnet, you can have application server subnet, web server subnet. Just keep in mind that Amazon reserves first 4 IP addresses and the last IP address of each subnet for networking purposes. You can create 200 subnets per VPC, and this is a soft limit. Please ignore the reasons in availability zone at the bottom. There should be reason, 1 reason, and multiple availability zone. It's a typo here. Moving on to the next picture over here. Now, we already discussed about an AWS region. Now we are adding more things to this building block, saying there are more than 1 region. You have US East 1 and you have US West 1. US West 1 is depicting 4 availability zones, while 1 is having 3. It's okay to have different availability zones in different regions. And you can see you have 2 VPC available in East 1 and 2 in West 1. We are going to talk about details on few services now that work within region or outside region, that work in a global level. Why do we need to have an application run in 2 regions? We need to run application in 2 regions, maybe in an active-active scenario or active-passive. Depends upon how your organization wants to run its disaster recovery scenarios or strategies. Having multiple regions will help in any disaster recovery scenario. You should design the application to have no single point of failure. Use automated monitoring, failure detection, and failover mechanism for both stateless and stateful components. It is recommended to have stateless components, as the replication of data from one region to another region in active-active scenario, it becomes more difficult if it is a stateful application. We already discussed about disaster recovery scenarios in a different video, so I'm not going to go into details of it, but just to understand that there are multiple approaches. You can have active-passive or active-active scenario where you want to run application in one region and keep the other one in a passive mode so that you can bring it up when a disaster hits, or you can just keep both regions working. In any condition, please look at the video for disaster recovery. Let's talk about some of the services. So we are going to talk about Route 53. What is Route 53 and how does it work? Where does it sit? So what type of service is Route 53? Amazon Route 53 is a highly available and scalable domain name system or DNS service. It brings you domain registration and health checking of web services. So Route 53 allows you to manage IP addresses listed for your domain names in the Internet DNS phone book. Amazon Route 53 changes are based on actual usage of the service for hosted zone, queries, health checks, and domain name lookups. So do you think Route 53 as a service is required to be hosted within a region or outside a region? So the answer is you don't have to run or host Route 53 within your region because it's a global service and it is managed by AWS. If you want to run your application in active-active scenario where you are running your application from two regions, Route 53 is going to be the real game changer there, because Route 53 will allow you to share the traffic between two regions based on different kind of routing policies it has. You can have weighted routing, you can have latency based routing, or you can just do a round robin routing. But based on several routing policies that you have in Route 53, you can just keep your application alive in two regions and serve traffic from two different regions. In order to make a global application, you'll have to use Route 53. Let's talk about the next service, Internet Gateway. What type of service is Internet Gateway and where does it sit? An Internet Gateway is a horizontally scaled, redundant, and highly available VPC component. Each VPC can have only one Internet Gateway. You don't have to pay anything for Internet Gateway as such. It supports both IPv4 and v6 traffic. It allows communication from VPC to the Internet and back. We talked about public and private subnet, these two subnets, the green and the blue, and we said green ones are public. Anything that is connected or anything having a route to an internet gateway, like in this case, if the subnet has a route to an internet gateway, this subnet will become public subnet. If the subnet doesn't have a route to an internet gateway, suppose in this case, this subnet is connected to a NAT gateway, which internally talks to internet gateway, this subnet will remain a private subnet. Let's talk about the next service and see where it sits. Application Load Balancer. Where does an application load balancer sit? So application load balancer is a single point of contact for clients. Basically, if you have a service, an application load balancer can share the traffic between multiple compute instances. So it will load balance all the incoming traffic for the application to multiple targets. The targets can be EC2, they can be Lambda, and they can be in multiple availability zones. So your application load balancer can work with multiple AZs. Application Load Balancer is a VPC component and it can be internal or external facing. You have three kinds of load balancers primarily in AWS. First one is Classic Load Balancer, which is not recommended. And we have specialized versions like Network Load Balancer and Application Load Balancer. Application Load Balancer allows you to have HTTP traffic, HTTP and HTTPS traffic. While Network Load Balancer is very good for performances, if you have some kind of high throughput requirement, Network Load Balancer is really good. Network Load Balancer operate on layer 4, while Application Load Balancer operate on layer 7, which is HTTP. Layer 4 is TCP. Running cost of both these load balancers and even Classic has been really low. There are certain scenarios where if you want to have WebSocket connections, you need to go with Application Load Balancer. With the Network Load Balancer, that is not applicable. Also, both Network Load Balancer and Application Load Balancer can route traffic to many ports on a given target. Another advantage of having an Application Load Balancer is that you can look at the incoming request, the HTTP request, with Application Load Balancer, and you can have routing decisions made on the Application Load Balancer. So both have their own pros and cons. Where to use and what to use is up to you. The bottom line here is, where do they sit? Are they globally available resources, or are they part of a region, or they are part of a VPC? So in this case, an Application Load Balancer will be a component of a VPC. Let's look at the next component over here, Lambda. Now, what type of service is Lambda and where can you run Lambda? So Lambda is a compute service. It's basically a container that gets invoked. It's called serverless, but it's not like there's no server behind it. There is always a server where it creates this container where this function is executed, and then within the given timeline, the function is terminated after like 15 minutes at max. Lambda runs your code on a highly available compute infrastructure, and the performance and other things can be administered. We have X-Ray for Lambda to look into the monitoring aspect of Lambda. Lambda runs your code on a highly available compute infrastructure and performs all of the administration of the compute resource, including server, operating system maintenance, capacity provisioning, automatic scaling, code monitoring and logging, etc. Functions are defined as images, and also you have a concept of layers in Lambda. If you deep dive into Lambda, you'll find there are concepts of layer that has been introduced for the last maybe 6 months or a year. Now, using layers, you can remove all the dependency from your code, and you can keep the dependency, reuse the dependency every time there is an execution. So basically, you can have layers of dependencies so that your real code, the business code, runs in a better way because it doesn't have to reload the dependencies all the time, and they're packaged as a layer rather than the part of the real code that is executing. So it improves the overall performance of the Lambda. When building an application with Lambda, you may need to host Lambda within your VPC, but when do you want to host it within a VPC? So Lambda as a service can be part of your VPC, or it can be global. When I say global, it will be executed. The compute instance is going to run, this compute instance is going to run within the AWS infrastructure. Without having any kind of association with your VPC, it can run. But when do you want to have this Lambda running within your VPC ranges? The common reason to do that is you want to have access to your domain resources such as relational databases. You want to access some of your internal service components that you're running within your VPC. In order to do that, you'll have to run or associate Lambda to run within your VPC. You need to associate what all subnets it can work with. By default, your Lambda function doesn't have any kind of access to the public network. To give a public network access, you need to add a NAT gateway in the public subnet, and you need to have your route from your private subnet that points to the NAT gateway. You're running Lambda within this particular subnet, which is private in nature. You can still run it within the public subnet. Let's talk about the next service now. What is S3? What type of service is S3 and where it is hosted? Now, S3 is a simple storage service, and it's an object storage service that offers industry-leading scalability, data availability, security, and performance. It's a managed service, which means the scaling, hosting, managing of the service, its availability is all taken care of by AWS. You need to understand that even though it is a managed service with a highly available architecture or high availability, you need to have an S3 bucket in each region where you want to replicate or sync your data. S3 bucket namespaces are global in nature. So if you have a S3 bucket in US West 1, it will not allow you to have the same bucket name in West 2. So giving you an example, this is an example of bucket. Bucket name here is my bucket prod US East 1. And that is unique. You cannot have the same bucket name in multiple regions. And that's the reason we are adding a region as the name within the bucket. The yellow highlighted of that particular path is called prefix. The first line, it says application 1. This one, application 1. It's a prefix. Application 1, module 1 is another prefix. These prefixes after the bucket and before the real file, these prefixes can help you scale your read and write request. Each prefix can achieve, it's a performance thing. If you put everything in an unorganized way, everything under, say, application 1, then you can achieve at max requests per second of 5,500 from minimum 3,500 to 5,500. But if you split those prefixes in a better structured way, if those structures match to your application requirement, the number of reads you can do, the number of requests per second for each prefix can give you that particular range from 3500 to 5500 requests per second. So you need to have a strategy in place to have these bucket naming as well as the prefixes, grouping of these prefixes in such a way that it meets your read requirement, meets your requirement to access S3. That's it, friends, for this week. I wanted to take this time, an opportunity to start talking about low-level components that sit in what kind of AWS infrastructure, where does it communicate from. So thank you for your time, and this is the end of this episode. I'll continue to add more and more services so that we can have a mental model about which service and where does it exist within the AWS world. Please like this video, subscribe it, and press the notification bell icon for future updates. I will request you to add your comments, give me some insight about what you want to look at, and I will certainly make that video for you.